All right, so just a quick reminder, your Google Getting to Know Me form, your parent information sheet, your syllabus forms, those are due today. I do have it set for midnight. So if you haven't done those yet, please do that so you don't lose late points. You also had that observation inference homework. That's technically not due till Monday, just because I wanted to make sure nobody was having problems. One thing I wanted to point out, because some students are not realizing this, and I understand why it would be confusing. When you're given a homework assignment like that in a Google Slides format, where you have to enter information, you don't want to go into present mode, okay? Because if you click present, you can't fill in the text boxes. You want to just keep it in the regular mode where you can see the pages on the side and the one in the middle, and you just need to zoom into the main page and then fill in the text boxes from there. So when we set up the activity that we do later, I'll just demonstrate that in case anybody was unsure how to do that. Okay, so looks like we have just about everybody. So we're going to go ahead and finish the notes for chapter 1. Share my screen. Can everyone see that? The observation versus inference slide. Okay, so this is what we did yesterday. We finished with observation versus inference. And we're going to just continue with one more aspect of the scientific method that's very important, just because when we do get back to class, even though we won't have an official double lab period, we will still be doing some activities in like single lab periods where you might need to use variables. Okay, so let's remind ourselves what a dependent versus an independent variable is. Okay, so first of all, remember that a variable, by definition, is something that changes. Okay, so sometimes it's a variable that you change, and sometimes it's a variable that changes because other things are happening. So the independent variable, the way I remember what the independent variable is because it starts with the letter I. It is something that I have control over in an experiment. So it's something that isn't changed by other things that are measured because you are the one that is controlling it. So for example, if you were doing an experiment where you wanted to see how much a plant would grow based on the amount of light, I can control the amount of light I expose the plant to. I really can't control its growth. I can't just say, hey, plant, grow. Okay, so I don't have control over that, but I do have control over the light. So in that case, the independent variable would be the amount of light or sunlight. The dependent variable then is something you don't have control over because it changes as a result of you changing the independent variable. So when I change the amount of light, it's going to affect the plant growth. So in that case, plant growth would be the dependent variable. So there may be occasions where you're asked to graph your data. So how do we effectively graph data when we have variables? Well, when you graph something, the independent variable will always go on the x-axis. Okay, the x-axis, don't forget, is the one that runs horizontally across the bottom. The y-axis then will be the dependent variable and it runs up the side. So this is what the graph would look like for that experiment. Because the light, or the amount of sunlight, is what I am changing, that is the independent variable, and that would go on the x-axis. The growth is the variable that we're going to measure because that's what changes, so that goes on the y-axis. And then you can see here that obviously the more sunlight something gets, the more it grows. Let's just talk a second about the title. Okay, so the title should always be independent variable versus dependent variable. So the most simple title for this would be amount of sunlight versus plant growth, okay? But that's like a junior high title, okay? That is not a good title because, yeah, it kind of tells you what's going on, but we want it to be a little more sophisticated. So another we can say is sunlight versus plant growth. We can say the effect of sunlight on plant growth. We can actually talk about what's really going on. Okay, so we're going to try to get a little more sophisticated with our graph titles. Okay, last part of chapter 1 then, and that will finish our notes for today, is on hypothesis versus theory versus law. And the reason I want to talk about this is because these terms are often used interchangeably and it's often confusing. So we're going to just go over the definitions really quick, but then there's going to be a 5-minute little video that does a great job with these. Okay, so a hypothesis is a reasonable guess based on what you know. Hypotheses are proven and disproven all the time, okay? So every time you do a lab in chemistry, you're going to test a hypothesis and prove or disprove it. Every time you have biology class lab, you did the same thing, okay? So they happen all the time. A theory becomes a theory when you have a hypothesis that gets tested over and over and over again, and it's always true, okay? So it's just something that's been always tested to be true. But it's not necessarily accepted by everyone because there's no way to absolutely prove it, okay? Like the Big Bang Theory, there's still a lot of people that are skeptical about that, even though it's always, the hypotheses have been proven true. The last thing is a law, and the way that differs from a theory is that it actually can be proven mathematically, okay? So they're generally accepted because there's math to back them. All right, so we're going to show a video here, and then after the video, I'll explain your assignment.
We need to get something straight. Evolution by natural selection is a theory. So is climate change. But people keep saying that like it's a bad thing. I get it. I understand your frustration. We're all searching for ultimate #truth, and complex, challenging ideas don't always fit nice and neatly in our brains. But what is truth? Are there different levels of truth? Are some truths truthier than others? Well, I don't know. But I do know this. Science is the absolute best tool we have for understanding how the universe works. And theory is not a 4-letter word. If we're going to trust science together, the least we can do is speak the same language. Words like fact, theory, hypothesis, and law mean something totally different to a scientist than the way they're used in everyday speech. So let's get them straight. Facts are really just observations about the world around us. And we observe things every day, like that it's bright outside when I look out the window. And we often develop explanations for those observations, like, okay, the sun is probably up. Congrats! We just developed a hypothesis. But a hypothesis isn't something you prove. It's something you test. So, let's walk outside. It's bright, the sun is up, hypothesis confirmed. Way to go! We did a science. We often come up with multiple hypotheses to explain an observation. We just eliminate the ones that are wrong. What's left over is not a theory or a law or an ultimate truth. It's just a possible explanation for something, one that can lead us to new hypotheses, which may agree or disagree with the original one. It's a never-ending story. only without the big fluffy dragons.
That's so good.
When enough hypotheses have gotten the old scientific check mark, we can pile these all up and turn them into something greater, a theory. A theory is the way we know something works, based on the evidence we've collected and all the hypotheses that we've successfully put to the test. The best thing about a theory is that we can use it to make predictions, and not just about the way things are, but how they will be. You may have heard someone say something like, I have a theory about why cats purr. I think it's because they're actually tiny robots, and those are their gears. Well, that's not a theory. That's actually a hypothesis. It's something that could be tested, but don't try this at home. This cycle, taking facts and observations, thinking up possible explanations, testing those explanations, and then making predictions based upon them, that's what this whole science thing is about. Being a theory isn't a bad thing. It means that idea got the gold star, the blue ribbon, a big shiny trophy that says, countless experiments have shown that I'm sufficient to explain all the observations that I encompass. Now, to see if you got this down, let's look at some examples. Fact, people get sick. I think we can all accept that. Hypothesis, people get sick because something gets in their body and starts doing bad things. Test each hypothesis, throw out the bad ones, and we're left with a framework that lets us understand why we get sick and make predictions. The germ theory of disease. Okay, let's try another. Evolution is a fact. We know that it happens, no doubt. But how does it happen? Evolution by natural selection is a theory. We've come up with thousands and thousands of hypotheses about it, tested them, thrown out the bad ones, and we developed a pretty darn good framework for predicting how living things change over time. So yeah, it's a theory. Stop saying it like a bad thing. Calling it a theory means it's passed the toughest tests that we can throw at it. And evolution has been tested maybe more than any other theory we know of. We should really call it the theory of the fact of evolution. What about something as fundamental as gravity? Is that a theory or is it a law? In science, a law is a detailed description, usually using math, of how something happens, like the movement of gas molecules related to temperature, or how mass and energy are always conserved. But a law doesn't tell us why something happens. Gravity, as it turns out, is a law and a theory. Newton's law of universal gravitation describes precisely how two objects will attract each other based on their masses and the distance between them, and gives us a nice formula we can use to figure it out. Textbook law. But Newton's equation doesn't describe what is happening or why. To do that, we need a theory of gravity. Fact. If I drop this, it'll fall. Law. I can mathematically describe how fast that apple and the earth will accelerate toward one another based on their masses and distance. But why is it happening? Hypothesis. There's a force pulling on the apple, or maybe there's something about the universe and the way it's structured that makes massive things fall toward one another. Or maybe the apple is like magnetically attracted to Earth or something. Eliminate the bad ones and we're left with a theory. And thanks to Einstein, we've got a theory of gravity called general relativity. But once scientists stumbled upon quantum mechanics, they began to realize that Einstein's relativity didn't account for what was happening on the very smallest gravitational scales in the universe. General relativity is still great at describing the universe at the scale that we interact with it. But even the theory of gravity is incomplete. Does that mean we throw it out because it can't explain everything? No. I mean, if you get a flat tire on your car, you get a new car. If you change the tire, is your car a different car all of a sudden? All of these fit together to make the scientific machine. We're constantly adding and taking away parts, but it keeps on running just fine. It just means we've got more work to do to make Einstein's theory even more right. Science is...
Okay, we're going to stop it there. Hopefully that gave you a better feeling for what those parts are. Okay, so that is it for chapter 1. I know all of your notes are not filled out yet because those are for chapter 1 and 2, so just hang on to those and we will use those again when we start chapter 2. So right now, we're going to give you an assignment. So this assignment is not hard, trust me. It's just an opportunity for you to get away from your computers for a little bit. It is worth 25 points, so it's a, it's a decent point assignment. You're going to want to do it. So what you'll need to do to access this, and if you want, you can wait until I go through it if you don't know how to split your screen. If you know how to split your screen, you can bring yours up in addition to what I'm showing you. You will want to go into Google Classroom, okay? And the reason we know this, if you look on the agenda here, it says begin working on scientific method activity, and then there was this little Google Classroom, okay? So if you were absent, you could see this and know that there was an assignment in there for you. Remember that we are going to the classwork, okay? So you always want to go to classwork. And since we're in chapter 1 and 2, you can now see that there is an assignment called scientific method practice. You'll want to open that. Okay, this will automatically make a copy for all of you, so you don't need to make a copy of this. All right, now remember, if you want to keep your documents organized, at this point, you would go up to this little folder and you want to move that into your chapter 1 and 2 folder inside your chemistry folder. Okay, so if you're making that effort at being organized, this would be a good time to do that. Okay, so remember I said that when I give you an assignment that is in slides, you don't want to go to present, because if you click present, then none of the boxes are clickable, okay? It's just going to put you through the presentation. So what we need to do instead is we need to bring up the sheet that we're working on, and then we want to just zoom in on that, okay? So depending on, you know, if you have a touch screen or you want to use your touchpad, or there's always this little zoom right here. Okay, you can zoom into whatever zoom power is good for you. And now you're just going to read through it like it was a regular document. Okay, so you're going to read the directions. You're going to get to some questions here. So wherever there is a question or a space to type, if you double click down in that area, it will bring up a text box and you should see a cursor, and then you can just type your answer right in there. Okay. Once you finish that page, you're going to go to page 2. Again, read it. What you're going to be doing is you're going to be building some paper airplanes. Okay, you're going to do a little research, pick a couple of designs, build them, fly them, and get some data. Okay, now you can use whatever tools you have around your house. Okay, so if you have notebook paper, use that, printer paper. If all you have is little sticky notes, then use those. Okay, but you need to be consistent. You need to tell me the paper you're using, and again, measure it somehow. Measure the flight, whether you have a ruler, a tape measure. If you only have your feet, your hands, whatever, you know, as long as you tell me what you're measuring with and you're consistent. This last section here, that'll be filled in after you do the experiment. Okay, remember, each of these has a clickable text box, so when you double click, you can type in them. Again, you're going to answer this. Then you're going to go to your next slide. Okay, this is the slide that's going to take the most time because you have to do a little research on paper airplane designs. So I want you to go to each of these links. They're either documents or videos. You're going to watch them and take some notes about what you learned for each of those. And then you're going to actually build your airplanes. Okay, so you're going to pick the 2 designs that you think are best. Give it a name. Either use the name that was in whatever document you found it in, or you can name it something that you want to name it. And then I need you to give me a picture of your design. Okay, so what you can put in here is you can make your airplane and then actually take a picture of it with your laptop webcam, or if you have a phone and know how to upload that, you can put that in there. If you can find a JPEG image of your particular design, you can insert it here, okay? But as long as I can see somehow which design you chose and what it looks like, that's gonna go there, okay? If you struggle with this is something you need to use the internet to help you figure out how to do, because you really need to learn how to insert pictures and or images into documents. Okay, so if you're really struggling, you can pop back on and I can try to help you with that. So you're going to do that for design 1 and 2. Then you're going to actually perform your experiment. This materials text box may not come up for you guys because I added that later. So if that doesn't come up, don't worry about filling that in. But the rest of these should be clickable. And then the last page, again, you can fill these in and just read the instructions as to what you're supposed to do. Okay, this very last piece is to help me know where your challenges may have come in with technology. Like I had a really hard time getting my pictures inserted, things like that. So I know where we may need a little bit more work. So you'll have the rest of this class period to work. So that's like another 15 minutes. And you're going to have Monday to work on this, which is way more than enough time to complete this. But on Monday, you will still need to check in. Okay, so at the start of class, you're still going to come, period 4. We're going to Zoom. I'm going to make sure everybody's here, and then I'm going to send you off. Okay, anytime I send you off to do work, I will always stay on the Zoom session. So what that means is if you're off working, doesn't mean you have to stay on, but you have a problem, you can just click the link, pop back into the Zoom, and ask me any questions you might have. Okay, so that way, you know, you don't feel like you're stranded without me. Okay, any questions about this? This won't be due until Tuesday. So, okay, so Google Forms that are due today. Your inference and observation sheet is due Monday, and then this won't be due till Tuesday. All right, you guys can sign out. I will stay on if you need me.